Okay, now what we're going to do now is look at 41 and 42, and it says explain why the groups are not isomorphic. So I just want to talk about 41 briefly. Notice that D4 has elements that do not commute. In other words, D4 is not commutative. If you had an isomorphism, it would map commutative elements to commutative elements. So since the rotation and the flip in D4 do not commute, and every last thing in here commute, as we discussed in class, you couldn't map those to anything. Now let's look at 42. Now here you have two groups that are abelian. Everything commutes. This group has order 8, right? Z4 has order 4 times 2. This group has order 2 times 2 times 2. Well, how do you know those are not isomorphic? Well, if they were isomorphic, so in 42, are Z4 cross Z2 and Z2 cross Z2 cross Z2 iso? Well, if they were, if there was an isomorphism, F from Z4 cross Z2 to Z2 cross Z2 cross Z2. Think about by homework problem number 29, right? Since I have an element here, the order of A equals the order of F of A. Well, but think about this. Here, I have an element of order 4, okay? So, we all agree that the order of the element 1, 0 is 4 in Z4 cross Z2. Well, why? Because 1, 0 plus 1, 0 plus 1, 0 plus 1, 0 actually equals the identity, and no smaller piece, of course that's not the identity, that's not, and so on. So that is the smallest number of times you can add it to itself to get back to the identity. However, but there is no element in Z2 cross Z2 cross Z2 of order 4. How can you see that? Because any element here, A, B, C plus A, B, C, well, these are all order 2. And everything order 2 goes back to itself. So it either has order 1 or order 0, right? So everything here, this is sort of my rationale for that. So there's nothing in here that has order 4. They all have order 2. If this is 1, if that's 0, if that's 1, if that's 0, so on. So this is a contradiction, right? We said it had to have something in the same order, but it doesn't. Therefore, F does not exist. The end.